static routing. In this lab, we are going to work on allowing PC1 and okay, so I guess this is PC1 though, right? Let's put this as PC2. This is PC2 and this is PC1. Straightforward, right? Okay. We're going to allow communications between PC1 and PC2, namely a ping. That's all we're really going to be doing, right? So in order for us to do that, we have to make sure that these routers have the appropriate routes in order for these two devices to communicate with one another. So routers have a routing table, as you know, and no communication is happening without sufficient routes in a routing table. So what we're concerned with routing, specifically in this example, is two-way reachability. And I say specifically in this example, not to say that when you use dynamic routing protocols, you don't have to worry about two-way reachability. Two-way reachability is a must. You must have a way to the network and back to you, right? If when you're sending communications. And that all happens in these routing tables. So what we need to do is, in order for PC1 to be able to reach PC2, we have to have a route to this network in this routing table, right? So a route to this network in this routing table. So it needs to know that, okay, in order for me to get here, what do I do? Where do I go? And that's what we're going to configure, right? In this specific router, we're going to specify or implicate this router in being able to, or knowing how to forward the packet in such a way that it'll eventually reach this destination, right? But before we even do that, I'm going to show you how to configure Dhcp on Cisco routers, and we're going to configure it on R1 and R2 so that PC1 and PC2 has IP addresses, right? So Dhcp servers can be configured pretty much on any device. It's a very lightweight, I'd say it's very lightweight protocol. It's very mobile. You can configure it on a computer, you can configure it on a server, you can configure it on a layer 3 switch or a Cisco router, right? Routers could act like DHCP servers too, right? So we go into CLI and enable enable conf t, and then we're gonna set up a DHCP pool for this network right here. So we issue the IP DHCP pool command, and we're gonna put the pool name. This is the pool name VLAN. It's gonna be VLAN 10, right? The network, we gotta specify the network with the network command 192.168.10.0 255.255.255.0, and then we're going to say that the default router is 192. Oops, did I even set it the default router? I don't think I set it up here. But we're gonna say 192.168.10.254 DNS server 1.1.1.1. So we set up the DHCP pool for our clients here. The next thing we need to do is we need to set an IP address. So hold up, do show IP int interface. Oops, that's not what I do. Show IP interface brief. Yeah, we didn't set an IP address on that LAN facing internet, and we need to do that because in order for our host, like we explained in the previous segment, in order for the host to be able to reach the DHCP server on the network, it has to be on the same network as the DHCP server, or the router has to act as a relay agent and direct that broadcast, not necessarily directing the broadcast, but directing that discover message or facilitating the DORA process between a host on one network and the DHCP server which exists on another network, right? But we're not going to get into that right now. Just going to configure them locally on each network, right? So let's exit out of this, and we're going to go int, which one was it again? I keep forgetting. Int G01 192.168.10.254. Oops, gotta add the IP address. And then we got to put the mask. .255.255.255.0. That's /24. And it's already not shut down. It's up, right? Okay, it should be up. Now, this host should be able to get an IP address. Let's activate DHCP on the host, and let's see what happens. It gets an IP address, and we know that because it gets its default gateway settings and its DNS server settings, but we can always double check in the configuration. So it's given an IP address of 192.168.10.1, and it has the rest of its information. I'm gonna do DHCP for IPv6 in another video. I've been neglecting IPv6. So yeah. So now we got that straightened out. All right. Now the next thing we need to do is set up DHCP on. I meant to put R3 here. Gonna set up DHCP on R3. All right. Same thing. IP DHCP pool name VLAN 20. Just call it VLAN 20, even though I didn't specify it on the switch. Network 192.168.20.0 255.255.255.0. Can't type today. The default router is going to be 192.168.20.254 because it has to be in the same network. And then Cloudflare. And then we're going to set the default gateway G01 and G01. Yep, we can go from subcommand mode to subcommand mode. 192.168.20.254 255.255.255.0. No shut. There we go. So now this device should be able to get its IP address from DHCP. Let's see. Yep, it gets its IP address 20.1, right? Now, again, remember, we need to set up these routes because it doesn't have any reachability. Let's see if we can communicate over. Let's see if we can communicate across the link, right? With a series of links that we have. Why is it lagging like this? Let me go ahead and save this. Okay. For some reason, my computer is lagging like crazy. Let me close some stuff. There's no reason for it to be lagging like this. I'll quit that. Free up some resources, even though this is a pretty solid computer. 20.1. Destination host unreachable. So when you get this message, you can kind of surmise that there's no route in the routing table, right? So now what we need to do is we need to set up these routes in the routing table. So for R1, we issue the IP route 192.168.20.0 255.255.255.0, and then we're going to specify the next hop. This is a recursive route which specifies the next hop, right? So the next hop address, as we can see here, is going to be 172.16.1.2. So 172.16.1.2. Keep in mind, I already set up all of the IP addresses necessary for these routers to communicate each other. I put them on the same network, right? R1 and R2 is on the same network. R2 and R3 on the same network, as you can see right here. This is a point-to-point network right here. Only 2 hosts. You need to make sure that you understand how to subnet a little bit and put these routers on the same network in order for them to communicate with one another, right? And that's what we're doing here. That's what we're allowing here. In order for this next hop to be valid, this router has to know how to get to the network that this next hop destination is in, that this next hop IP address is in, right? So let's go ahead and issue that, and let's check the routing table. Do show IP route. So we issued this recursive route, right? And again, remember, we need a network here in order for this IP route to be valid, because if this IP route is not valid, if this IP route is not, if this router doesn't have a path to this network here, or to this to the network that this IP address exists in, this route is not going to work. So let's see if it even has one. Yeah, there it is, right here, right? This is saying the C stands for connected. It's saying that it's directly connected to this network in which this IP address belongs. And again, I go over these routing tables a lot because you need to know how to read these routing tables. Very important. Not hard. You just, look at it and understand what it's saying. So this is saying that this local route, right, which is specifying this interface right here, because it's a /32. All 255s means that it's this host, right, is directly connected to G00. So it has a way to get to this IP address because the network is in the routing table. It's directly attached, right? And you can see that our IP route command was entered into the routing table. I put emphasis on entered into the routing table because just because you enter it and the iOS accepts it doesn't mean that it's going to enter into the routing table or even work, for that matter, for the previous reasons I listed, meaning having a path to this network via another route that's in the routing table, right? Having a path to this IP address, this host, via a route that's already in the routing table. So we see that it's here, it accepted it. Now, let's see if we can reach it now. Let's see if we can reach that network. Request timed out. It still can't reach it. Why? Because this router here now was implicated in this router's routing table with regard to how to get to this network. But this router does not know how to get to this network. It doesn't have a route in its routing table for that network. Let's check. Do show IP route. No, it doesn't have a route to that network. All it has is the routes to the networks that it's directly connected to. So how about if we put a route in this router that says that it is in fact directly connected to this network right here. And that's going to be a directly attached static route, right? So what we're going to issue is, I'm just showing you different flavors of static routing. So IP route 192.168.20.0 255.255.255.0. This is a network route, right? But it's directly attached, right? And then we're gonna say you can reach this network out of this interface. Save it real quick. It says default route without gateway. if not a point-to-point interface, may impact performance, right? So it's important that it's a point-to-point interface in order for this to actually work correctly. Why is that? Because now it needs to be directly attached to a router that knows how to get to this destination, to the destination that's specified in the IP route command, right? So now let's check the routing table. Do show IP route. Okay, now it's saying, all right, in order to get to this network, you can send the packets out of this interface, right? So that's what it'll do. And then now let's see if the router can ping, right? Because now it knows how to get to the network. See if it can ping that host. Still can't reach it. Why? Why can't it reach it? So now let's check this routing table. This network, this router knows how to get to the network, right? It's directly connected to gigabit Ethernet 01, right? So it knows how to get, it knows how to get there. The issue now is this router right here doesn't know how to get to the network that the source address of that ping belongs to. So in that packet, when we're sending the ping across this link, this whole network right here, to this host, the packet is saying this, right? This source is 192.168.10.1. The destination is 192.168.20.1. This router here knows how to get to this network, but now on its way back, the source and destination needs to be flipped, which means that when this packet, when this host replies, the source and destination is going to be flipped. So the destination is going to be 192.168.10.1 and the source is going to be 192.168.20.1. It's going to hit this router. The router is going to look at the packet and go, do I have a destination? Do I have a route for this destination IP address? Let me look at my routing table. It looks at its routing table and it doesn't see it. So it drops the packet. That's what routers do by default when it doesn't have a route to a destination. It just drops it by default. Now you can set up a default route, or you can, you can set up a default route or specify the specific route. In this case, that's what we're going to do. We're going to say or assume that router 2 knows how to get to this network. So we're going to specify that. Once it gets the packet, it's going to send it to the router, right? That is connected to 168.10.0, 255.255.255.0, and then we can say, you know what? We're gonna use a next hop. We're gonna use a recursive route, right? So we're going to input, make sure I got the IP address right. It's gonna be .1, right? 172.16.2.1, right? Making sure I have the right one. So now it has a route to that network. So now when it receives, when router 3 receives a packet from this network going to this network, it's not going to drop the packet. It's going to forward it here. But this router doesn't have a route to this network. Because remember, this router is assuming that this router knows how to get to this destination. Does it? Let's see. It doesn't, right? So now we need to enter the appropriate command, and we can use another directly attached route, but we don't have to. We're gonna use a recursive route again because it's just mixing it up a little bit. So IP route 192.168.10.0 255.255.255.0, and we specify next hop of 172.16.1.1. Right? Now let's check the routing table. Now it knows where it's at. You know it can be reached via this network, this IP address right here. And it has a route to that host's network. Again, remember, in order for a recursive route to work, the recursive route specifies the next hop, but the router needs to have a route to that next hop IP address, right? So don't skimp on that. So now let's test the ping. Now it has a reply. So let's think about that for a second. Two-way reachability. Two-way reachability says that we need to have a route to the network and a route back. So this PC sent the packet to R1, to that network. This router says, oh, I know how to get to that network. And it sends it to R2. R2 goes, oh, I know how to get to that network. And sends it to R3. Oh, I know how to get to that network. I know how to get to that network. It sends it straight to PC2, right? Keep in mind that when you're sending the packet across the network, the source and destination address stays the same all throughout. They don't change, right? It's operating on layer 3. Source and destination IP addresses don't change. The only thing that changes from here to here, from here to here, here to here, here to here is just the MAC address, right? Because as it's traversing that link, it's passing through these physical nodes, and on the layer 2 side, that's the language that the switches speak, and R1 has to speak the language of layer 2 so that it can communicate with the switch, and that's what happens within the frame, right? So you got the frame, and then you got the packet. Source and destination does not change as it's traversing, right? So that's pretty much that. To troubleshoot these routes, or to troubleshoot, a failed ping, check for, if I was you, I'd start with layer 1 and go up, right? You could start with, is the cable disconnected? Is the interface shut down for some reason? Check the up status, right? Also, again, as we spoke about before, in order for recursive routes to work, you can have this table here all you want. You can have this route here all you want. You can enter it. Not going to guarantee that it'll work. What's going to guarantee that it works is that this host, right, is reachable through a specific route, which is here, right? It's reachable, right? If this host interface is down, again, doesn't matter what you specify in the routing table. It's just not going to work, right? So that's what I want to say about that. As far as troubleshooting, I'm trying to think of anything else. Static routing was a huge shift for me with regard to learning this routing and switching stuff, because I remember spending like 8 hours on the lab one day trying to make my Cisco home lab work, meaning the hosts could ping each other and everything. And I had to write up so many static routes, because what I did was I had a 3-router, a 3-switch setup, or I still have a 3-router and 3-switch setup, and I had 2 VLANs on each switch. So I wanted, and I made sure that a host was in each VLAN. I wanted to make sure that each host can communicate to each other host on each other VLAN, but I didn't have any knowledge of dynamic routing protocols. So I had to write all of those routes in each routing table. And it was a pain in the ass. Until I learned dynamic routing, which is through OSPF, EIGRP, never use RIP or ISIS. But I used those two routing protocols, and it made this stuff a lot easier for me to understand, to configure, even in my home network. I feel confident that I can go into a job, and I don't necessarily think that they'll let a CCNA work on production, but I'd be able to actually just look in the show command without fooling around or touching anything and say, okay, yeah, this is what's going on with the routing situation, right? Or at least I can make some educated guesses. So that was the Cisco lab that I had planned for today. I did this lab because, again, it was a lab that was brought up in the middle of the week. Decided to execute it, and it was pretty straightforward. Once you learn static routing for IPv4, it's simple and straightforward for IPv6. It's essentially the same thing, with just little tweaks here and there when you're talking about link local addresses. When you're specifying, and you'll probably come across this later on and realize what I'm talking about, but when you're specifying a link local address, or when you want to route to a link local address, you have to issue or configure what's called a fully specified static route, which is a static route that specifies the exit interface and the IP address, fully specified. So there's essentially three types of static routes. There's the recursive static route, there's the directly attached static route, and then there's a fully specified static route. And there's few other types of routes that you should know, static routes that you should know. You should know what a network route is and what a host route is. Network route is simply a static route or a route in general that routes to a network. Host route is simply a route that routes directly to a host, right? So you can have in your IP route that you want to get to a server over a specific route or specific next hop, right? So you can do 192.168.10.1, 255.255.255.255, and you can say send it through this router right here. Might have a shorter path, less traffic, I don't know. It might just be the case, right? You could do that. Invalid next hop address, but yeah. I don't know. Yeah, you can just enter it. It's not gonna be, this is not a real thing, right? Just showing you an example of how, despite the fact that we don't have any of this in the topology, where is it? Yeah, see, we're saying, yeah, to get to the server, just send it straight here, right? So you can send traffic with static routes. You can send traffic over various paths, and you can also fool around with that with regard to dynamic routing as well. You can manipulate the routes in such a way where you send prioritized traffic over, use a primary traffic link for a specific server, a specific resource, and it's no big deal, right? So that's pretty much it. I'm about to lock up the stream right now, and that was it's pretty straightforward, pretty fun, and I will talk to you guys next time. Peace.